Friends, let me now explain you how to solve simple problems in psychrometry. For that, you need to know two expressions at least. One is the expression of specific humidity and other is the expression of relative humidity. Specific humidity expression is in terms of partial pressure of water vapor PV and the total pressure P. PV is the partial pressure of water vapor. It means that it is the pressure exerted by the moisture which is present in the given air. So, some way, if you calculate PV and you know the total pressure, then you can calculate specific humidity by this formula. Omega is equal to 0.622 PV upon P minus PV. The other expression you must know is relative humidity, and that is calculated by the formula PV upon PVS. So PV, I already told you, is the partial pressure of water vapor, and PVS, this PVS, or it is also known as PS, this is the partial pressure of water vapor when the air is saturated. Okay, so when you keep on adding the moisture in the moist air, the pressure would start building up because of water vapor, and finally the water vapor no longer can be accommodated. So the PV would become PVS. Okay, so the point 1 would shift to 1 dash and the pressure would increase from PV to PVS. So this is basically saturation pressure of water vapor, right? So now we need to know what is PV and what is PVS to find relative humidity phi. So how do you find PV? So for finding PV, if your dry bulb temperature is given and dew point temperature is given, then you can easily find the PV and PVS. So if your dew point temperature, this is your dew point temperature is known, then you understand from this diagram that the saturation pressure corresponding to dew point temperature is your PV. Similarly, if your dry bulb temperature is given, this is the dry bulb temperature, then the saturation pressure corresponding to this dry bulb temperature, this is your PS or PVS. Okay, so PV is saturation partial pressure corresponding to dew point temperature, that is saturation pressure corresponding to dew point temperature, and PS or PVS is saturation pressure corresponding to dry bulb temperature. So in the problem, generally dry bulb temperature would be given and dew point temperature would be given, and if they are given, then you can find PVS or PS and PV, and the ratio of the two would give you the relative humidity. Similarly, you know the total pressure, you know PV, then you can find the specific humidity. One problem I would like to discuss. In a problem, it is given that, so in this problem, specific humidity is given, is to be calculated, omega is to be calculated, relative humidity is given 60%, and the dry bulb temperature is given 30 degrees, and the total pressure is given P 101.3 kilopascals. You are required to find omega. Now you know these two relation. Omega is 0.622 PV upon P minus PV, and you know RH is equal to PV upon PS. Okay. We have already said that when the dry bulb temperature is known, we can find PVS. So this is what we do from the steam tables. We find the saturation pressure corresponding to dry bulb temperature, and that becomes PS or PVS. So this is one thing. We got this. This is 4.241 kilopascal. Now in this problem, this is already known, 60%. So you find PV in this way. Once you get this PV, put it over here. This total pressure, put it over here, and you find omega. So that is what is done. So we find PV. This is PV. Put that PV here, and you get omega, which is 0.016 kg of water vapor per kg of dry air. This is how we calculate the specific humidity. This is one type of problem where the relative humidity is given, dry bulb temperature is given, and total pressure is given. The second type of problem is when you are given the dry bulb temperature and dew point temperature. You are not given the relative humidity and you are required to find relative humidity and specific humidity. Again, you use the same two formulas, this one and this one. Dew point temperature, you know. From that dew point temperature, look for the saturation pressure corresponding to 15 degrees centigrade, because 15 is the given dew point temperature. You get PV. So that PV is 12.79 mm of Hg. You can convert it into Newton per meter square also. Similarly, you know dry bulb temperature. Dry bulb temperature gives you PVS or PS, also it is called as PS. That also can be found out. Now once you get PV and PVS, the ratio of the two is relative humidity. This is one answer. For finding specific humidity, we need to know total pressure. So total pressure is given. So suppose the total pressure is 101.13 kilopascal. Okay, so that if you use, or so that is corresponding to 760 mm of Hg. So this 760 mm of Hg is 101.13 kilopascal. So 736 how much? That way you can calculate the total pressure. Okay, or you can substitute it in mm of Hg also. For example, 736 you can put it over here. PV you already know, this is 12.79, and then use this formula 0.622 PV upon P minus PV, and that gives you the specific humidity as 0.011 kg of water vapor per kg of dry air. So this is how you calculate the specific humidity and relative humidity once your dry bulb temperature and dew point temperature are known. Okay. The third type of problem is when your wet bulb temperature is given and dry bulb temperature is given. Dew point temperature is not given. Dew point temperature is not given. Okay. So in that case, we use this equation, which is called as a Carrier's equation. Okay. And in this Carrier's equation, we substitute the value of PV dash. Now what is PV dash? So PV dash again you find from the steam table as the saturation pressure corresponding to the wet bulb temperature. Here you need to understand that it is wet bulb temperature. You should refer to the steam table. Okay. So as I said, you must look at the saturation pressure corresponding to wet bulb temperature. So that is PV dash. Put the PV dash over here. P is the total pressure which would be given to you. Suppose in this problem it is 750 mm. So put that as 750 mm. Temperature T is the dry bulb temperature here. And T dash is the wet bulb temperature. Okay. So for example, in this problem, 23 is the T dash and 35 is T, dry bulb temperature. Once you put all these values, you will get a value of PV. So this is the expression which is used to find PV when the dry bulb temperature and wet bulb temperature are known. So this way we get the PV value. Once you get PV, and because you know dBT, dBT would give you PVS. PVS at dBT is 42.4. PV you have found from this formula, the ratio of the two is relative humidity. And omega, again very simple, PV upon P minus PV. PV you have calculated and P is the total pressure. Okay, this way you find the omega value.